I'm happy to introduce you my talk. I'm the CTO of Amdocs. Just one sentence on the company. We are a 27,000 employee company focused on solutions for telecom company, phone companies. That's the only thing we do. And today, I'm going to talk with you about the telecom network of tomorrow and also how you can learn from a mistake that you may do in the future. So to begin with, what you see here is a picture from what you have inside phone companies. These are boxes, physical boxes. They could be routers, they could be firewalls, they could be mobility gateways, and it's a very complex operation because there's thousands of locations around the continent which has this mess, okay? If you, for instance, want to add another type of function to the network, let's say you want to support a 4th-generation network and not 3rd-generation network, so you have to take a physical box or boxes and send them to thousands of locations. And then you connect them, and as you see on the screen here, it's pretty messy. Probably in a German-speaking country, it's less messy, but at the end of the day, it's a very complex thing. That is the traditional network or the network of today. As of 2.5 years, there is a new concept that is saying, why don't we replace, I mean, the picture you see here is a physical element, right? So element number J could be a firewall, element number E could be a router. That's a physical element. Why don't we just use, instead of physical elements, why don't we put logical element, virtual machine, which will emulate the same functionality, okay? And then, instead of having that mess, we'll put everything on a server. Okay, and that looks much more organized. So if you think of the picture of the left, which is physical elements, the picture of the right plays the same function, but with virtual element. So now you don't need to have spare parts. You don't need to send the boxes to thousands of locations. You just have the server. And if you need another firewall, you don't buy a firewall. You instantiate a virtual machine of a firewall. This technology is called NFV, and everybody agrees that a decade from now, that would be how telecom operators will run. So for instance, if we put enough servers in this room, this could be the master office of Telecom Austria. Because we're just going to put this machine, whatever function they have, a router, P gateway, S gateway, MME, you don't really have to understand all of the functions. It's going to be virtual machine instead of a box. You just need to put them. The only thing you need to take care of is to orchestrate it. You have to connect those virtual machines to another, okay? Because in the picture I show you in the beginning, they are connected with wires. There's a physical connectivity between them. Here we're talking about virtual machine. So there has to be a logical connectivity between themselves. For instance, item E and H are connected on the right side with a virtual connection. On the left side, there's actual wire connecting these boxes. And they are thought to be better in terms of cost reduction because boxes break, but software doesn't, okay? So when you buy a software element, you can keep it forever. It's much more efficient in terms of operation because you don't need to have spare parts. You don't need to run inventories of boxes. You don't need to ship some box to some site with a van or with a technician. And it's also considered more agile. Agile because you can do stuff easier. For instance, let's say you want to have, as a phone company, a connectivity company, you want to provide service to enterprises, let's say Bank of America or with many branches, right? So one option would be to send somebody with a van and put a firewall security service. You'll put a firewall or intrusion prevention or antivirus or stuff like that, and you have to go side by side and put all of those physical elements. That's the left part of the slide. But what you can do with this virtualization of the network function, which is referred to as NFV, you can do the same by running them in the cloud and creating the antivirus, creating the intrusion prevention, creating the firewall, and placing them inside the network. So that is the story of NFV. That's a trend that started 2.5 years ago. But we talked about learning from mistakes from the future. So I was very fortunate to be part of the creation of this type of environment, this type of project for a phone company called AT&T in the US, a telecom company. And at some point in time, when we were in the process of making this project, we decided to have an offsite, which means we sit in a hotel, all of the people that are doing this project, and try to analyze how the project is going. Now, the essence of the project is not doing the actual virtual machine of the firewall or the router. This would be done by Cisco and Checkpoint, the company that makes routers and firewalls. The essence was how we do the orchestrator, how we do the layer that actually connect all of the virtual machines, upload the image to the virtual machine, control the cloud, and make everything work. So this is kind of, like an orchestrator in an orchestra. That was the intention. The exercise that we used in order to analyze if we're going to be successful or not is an exercise called Premortem Analysis, okay? Post-mortem analysis is where something goes wrong or somebody, somebody dies, and you dissect the history of what went wrong. Pre-mortem analysis is a proactive, very positive exercise. What do you do with pre-mortem analysis is stop doing what you're doing and sit for a second and say to yourself, let's assume, hypothetically, that the project failed. We're sitting now 4 years in the future and having a fireside discussion of how did we fail. We didn't fail, right? But let's say we did. And then we need to find out what was the reasons for the failure. In the future, once we find the reasons for the failure, we can go back in time because we are 4 years into the future and identify them and fix them today. This is a very powerful exercise, whether you work for a startup or a small company, and I really encourage you to try to do it. The beautiful thing here, there's two great things in this exercise. The first thing is that when you are in the future, there's still time to go back in time. And the surprising thing for me was that people really understand what are the difficulties. It's unconsciously in their head. They're doing the day job because they have an assignment and they have deadlines and they have to do stuff. But subconsciously, at least, they know what could go wrong. And when you have this exercise, people put Post-it and so forth, you immediately find few clusters of problem. By the way, this was the team that did this exercise. Highly recommended. When we did that, we identified 2 reasons that could mean that the platform won't fly. We identify, we'll talk about them, explain what we did to avoid this from happening. The first reason is cost. So clearly, servers are cheaper than tailored router and boxes and so forth. But it seems that the costs are higher. I will explain why. And the second thing is culture. Let's start with culture. The culture of most phone companies is when they want to resolve a problem, usually they will call the customer support of the router company or the telecom company that provided the product, and they will come to fix. When we're talking about virtual network, it is the operator who needs to fix problem. And if you know, sometimes you would say, we have a strategy, we'll change the culture. Not so easy. There's a statement called, culture eats strategy for lunch. Okay? When you have an organization and the culture and the strategy are not aligned, usually it's the culture who wins. The second thing is the cost. We talked about the cost. So let me explain to you what is the cost to have a telecom service which is virtualized. Firstly, you take the virtual machine of the firewall or the router and so forth. You onboard it, right? Once you onboard it, you have it on, that's one element you have on the design palette, and you start creating the service. I'm going to create a service with a 5G element connected to the antenna software connected and so forth. You add the software, the workflow, and the policies, and you test it. And once you've tested it, you package it, and then it runs. This process is very, very expensive. So clearly, software is much simpler and neater than the clutter of boxes. But this process is very expensive and takes a lot of time and a lot of labor. I will tell you even more. Once you run into operation of the virtual telecom network, and we have done that in life, you will encounter the following situation. What you see here are three organizations. The organization in the middle is CSP, Communication Service Provider, or phone company. On the right, you see the company that creates the software that orchestrates all the virtual machines. And on the left, you see the company that created the actual virtual machine, the firewall and so forth. So let's say there's a problem with the router. The operation people in the company will go to engineering. They say there's something problematic here. The engineering of the company, the phone company, will go to Cisco, Juniper, the company that makes the router. They go to technical support. They will go to product development and validate that there's a real problem. Now, product development would say something like, wait a second. It's true, the router is not working very well, but that could be connected not to the fact that there is a problem with the router. Maybe, step 5, the orchestrator is not orchestrating the firewall well. So now you have to talk to the people who make the orchestrator. And then, after 6 weeks, real developers start to work between each other, because up until now we're talking about product management, which describe the type of the problem to each other. They communicate what is the problem, but coders are not in the loop. So now we have developers and testers, and everybody is getting into it. Eventually, at step 8, we have several countries, about 18 tickets, 4 ticketing systems. What you really need to do now is to have a meeting in some exotic hotel somewhere where everybody goes and meet and try to troubleshoot the problem. That is a very, very costly solution, because every time there's a problem, 3 organizations and a dozen sub-organizations need to somehow interact between themselves, and it's a very, very painful process. If you do everything with open source, we thought about maybe we do it open source. Let me give you another solution. Same problem goes with operation. They go to operation are the guys in a phone company that are in charge of making things work. They see a problem, they go to engineering. Engineering goes to the vendor of the application, the router. But this time, if the router would say, I want to, the orchestrator is the problem, that's different, because now we're talking about open source. If you think that the orchestrator is the problem, If the orchestrator is an open source orchestrator, you should fix the orchestrator. Don't tell me now that you want to open a ticket for some other product to run. Tell me something else. If the orchestrator is not working, make it work. You are empowered to, instead of sending a ticket, fix the orchestrator, because this is the orchestrator that is running a telecom network, and your element needs to run on this orchestrator. And if it's not, it's your problem, because now you're empowered to fix the orchestrator. And what you see here, basically, is very similar to DevOps cycle, because at the end of the day, you have, indeed, you have a free organization, but it's a coding question. There are coders in all of those organizations, and they are empowered to fix the problem. So we had two options. One of them is proprietary solution on the right, okay, where every problem goes and becomes a troubleshooting issue. And the other option was to make the orchestrator an open source orchestrator. Not only open source, even massively deployed open source, because we wanted every telecom operator in the world to use that orchestrator. Why? Because once you do that, then all the people who are making the NFV application, the virtual machines, they will make it tailored to run on that orchestrator, because it's becoming the de facto standard. So what we eventually did, instead of keeping everything to ourselves, we chose the open source, and we started as a project which turned into a Linux Foundation project. Linux Foundation is the organization that manages open source projects. For instance, Linux is an open source project under Linux Foundation. OpenStack is an open source project under Linux Foundation. Anup, which is the open source NFV project, is under Linux Foundation. We merged with some company, and this is becoming the de facto standard of the telecom industry. So if you're a phone company, probably several years into the future, your network will be managed by Anup. If you look at the amount of partnership, of company that joined Anup, you will see most of the phone companies: China Mobile, China Telecom, AT&T, Verizon, Comcast, Vodafone, Orange, you name it, Bell Canada. Actually, if you combine the amount of subscribers of all the phone company that chose to have virtual network with Anup, open source virtual network, the number of subscribers is about 57% of the people in the world. So 57% of the subscribers worldwide are subscribers of phone companies or mobile companies or fixed line companies that have made a decision to join Anup. And what they are getting is it's open source. The orchestration of the network is open source. So B, they are in control. If something is wrong, they can fix the problem. They are empowered. Their engineers are empowered. Their coders are empowered to code the system. And since it's open source, they will never be stuck with a certain supplier, because they can, they could hire some consulting company to do SI for this, services for them, but if they're not happy, they can move to another service company. So now, as an operator, you are reducing the cost, you're using open source, you are really agile, you can run fast, and you can benefit from this. So the reason I think this Anup, this open source project, and I'm blessed, I'm fortunate to be on the governing board of Anup, inside the Linux Foundation, inside this federative organization. There's two reasons why it will fly, and again, it goes back to the exercise that we have done. We stopped our work Forget about your assignment. There's no weekly. You were supposed to deliver something tomorrow or by the end of the week. Stop. You're not supposed to do it now. Let's sit together and really crystallize what could fail, or do this Premortem analysis. Once we do this, we're really going to have an interesting discussion about the real open discussion about the problems. And I was looking at my employees and and they are talking about the problem that could happen. Why you never told me that there's a chance to fail? But people really got it out when you open the environment to have this discussion with this exercise. So we talked about cost. People were very concerned about the fact that we take a virtual machine from a vendor, it doesn't really fit to the orchestrator. It's not really ready to run on the orchestrator now when it's massively deployed open source. Not just open source, it's deployed in all of the operators. 60% of the operators, the people who makes the virtual machine will take care to do it right and to do it tailored to run. And secondly, the culture. The culture of telephone companies will turn to a culture of developers. Engineers are not necessarily coders, okay? In this conference, all the engineers are coders. But we are talking about telecom engineers. Sometimes they don't always program. They connect elements and so forth. The telecom engineer of tomorrow will be software developer. And that entails a training program, and that entails recruiting people that are computer science graduate, and that entails these factors. So with this, I specifically made a short session in order to hear your question, and I understand that I'm the last speaker, so I'm separating you and dinner, which is a very prestigious role. So with that, I open the stage for questions, if you have. Thank you very much. Can Anup principle be easily applied in BSS stack, and when do you think it will happen? Basically, the BSS stack that you're referring to is the billing and the customer service. So Anup is mostly related to managing the telecom network. It's a network element. So I'm not sure it's going to run there. Have you heard of RESTConf? Of course. And the Yang data modeling language. Yes, I believe it. The answer is very shortly, yes.
He's on questions. He's on questions. Okay, so let me just come and have a look. So we're at questions?
No.
Yeah?
No, I think I'm done.
You got it?
Yeah.
Are you sure?
I am.
What we got? Okay, so let's ask a couple of questions, and then what we're going to do, because we're ahead of time, is we're going to break a little bit earlier, and then you'll have the time to come back at 4:30. No, 5:30. Right, so, because we have lost some time. So let's ask a couple, and then we'll go from there. So, have you heard of RESTConf and the Yang... Oh! Disappeared. Yang data modeling language, and do you think that these technologies have a place in this field in the future? So
the answer is clearly yes, and I think they are used. Yang models are part of the models that will be used.
Okay.
It has a substantial part in Anup, so the answer is clearly yes. Okay,
great. All right. So, what role does open hardware play for RF components?
Offline. I'll take this one offline.
Sorry?
I will take
you
this
answer
offline.
It offline?
Yeah.
And should we do the last one offline? Do you want to do the last one, or should
What
we
are the best open source orchestrators? So the best, in my opinion, there's a bunch of orchestrators.
Okay.
Most of them are proprietary by
Right.
some orchestration vendor. The open source orchestrator that exists today is Anup and OSM, and I'm clearly biased. I think I wouldn't even call it best. The Anup is the orchestrator that is supported by, as I said, almost 60% of the telecom population. So we are talking about something that is becoming the de facto standard. So I would refer to it as the best, although I'm coming from a biased opinion.
Background, okay.
Yeah.
Have you seen something that's taken your interest, piqued your interest there in the questions?
Best practices would you recommend for the pre-mortem analysis? I think what the best practice to do it, get some team together, leave the office. You cannot do it in the office because there's going to be phone calls and some customer has a crisis and there's always like that, right? So what you really want to do, if you want to have that, you need to go to someplace that is off-site. Then you can take a moderator. It's very expensive, but you should consider doing this. And what you usually do is put people into this environment where, like, we're not going to fail, right? But let's assume we're going to fail. And then you start with everybody writing a reason for failure on a post-it. And then they put the post-it on the boards, okay, a magnet or some boards. And then you would see a clustering phenomena, because eventually there would be 2 or 3 major potential reasons for failure. And you look at the cluster, you say, okay, you wrote it like this, and you wrote it like that, but in the end, you wrote the same thing. Now, let's understand that we have 3 major issues that could mean that our startup is going to fail, okay? And then you need to really resolve it by the way we did it with the consultant. We separated ourselves to 2 groups, because there was 2 clusters. Each group dealt with 1 cluster, presented what they came up with to the rest, and then we come to the conclusion in a pseudo-democratic manner, how this went.
Great. So we're going to leave it there for now. You okay to do that?
Yeah.
Yeah? You got another one you want.
Who's the most innovative CSP from your point of view? So AT&T. That is my
AT&T? Yeah. They are the most. Who asked that question? Are you happy with that? I just wanted to check. Or did you? Sometimes people ask the question, but they've actually got a kind of like a counter response. All right.
It's not.
So, Eyal, thank you so much
for
being here with us.